Welcome to today's lesson. In this tutorial, we will write the equation of a function given its graph. So we've already looked at transformations of functions, and now today we're going to be going backwards. Instead of I give you an equation and we look at the graph, now we're going to be given a graph and we're going to write the equation. So let's answer some questions first. What is the name of the parent graph of this function? So here's the graph, and you should be able to identify that this is the graph of a cube root. So that's what we're talking about here, a cube root function. So the general form for a cube root would be y minus k equals a times the cube root symbol of x minus h. Now you can do the y minus k, or some people will just do y equals and put plus k over here. And that's fine. Either one of those, of course, is acceptable. In words, let's describe how the parent graph was transformed into the graph to the left. So what must have happened to move the parent graph to where this graph is first? I think the most important point to find is sort of our starting point. And I can see that our starting point is right here in the middle, and it's right here. That will help us to figure out what h and k are. So since this point is here, this graph must have shifted to the right 2 units and shifted down 1 unit. So in words, we shifted right, and I'm going to say exactly how many times, 2 units, and we shifted down 1 unit. Now let's talk about the value of a. Our normal outputs when a is a regular 1 would be for the cube root. If we input a 1, if we go to the right 1 unit, we should be going up 1 unit, and it looks like we are. And when we go over 8 units, which would be the next perfect cube, 1, 2, 3, 4, 5, 6, 7, 8, just a little bit off, we should be going up 2 units. And that looks about right. And it's also symmetric sort of over here. So I'm going to say that we did not shrink or stretch or anything, that A is normal. So in part D, where it says state the value of A, H, and K for this transformation, A remains at the normal value of 1. H, because we shifted right 2 units, is a positive 2, and K, because we shifted down 1 unit, is a negative 1. So really finding this point right here is incredibly helpful to write the equation because that gives us the h and it gives us the k. Now when we want to write the equation of this graph, we know all of the numbers that need to go in here. So I'm going to say y, since k is a negative 1, this will become plus 1 is equal to a, which is just a 1, so I'm not actually going to even put that. I'll put the cube root. Since h is 2, this becomes x minus 2. And if you'd rather not put k over here with the y, you can simply write it as y equals, and then the cube root of x minus 2, and then put minus 1 right there for k. Either one of those is acceptable for the equation of this cube root graph. So that's what we're doing. We're going backwards. We'll look at one more. Part A says, what's the name of this parent function? Well, this is clearly a quadratic function. The name of this graph is a parabola. It is quadratic. This is the quadratic function. It says state the general form, so I'm going to write y minus k is equal to a times quadratic would be x minus h in a set of parentheses that's being squared. And again, I just choose to put the k with the y. Some people put plus k over here so that they can have y equals. In words, let's describe what happened to this parent graph to get to this graph on the left. And again, it's important to find that initial point, that sort of that starting point. It's right down here. It's called the vertex. So now I know that I've shifted left 1 unit and I've shifted down 1, 2, 3, 4, 5, 6 units. So I've shifted left 1 unit and I've shifted down 6 units. Now that I see where we have shifted, let's talk about the value of A, because it looks like A is not normal in this one. It looks like this quadratic is a little bit narrower than normal. If A were normal, the normal 1, when I input a 1, when I go to the right 1 unit, I should be going up only 1 unit. But it looks like I've gone up 2 units. And for a quadratic, when I input a 2 or go to the right 2 units, I'd be going up 2 squared normally, which would be 1, 2, 3, 4. But that's not where I am. I'm actually 5, 6, 7, 8 units. I'm up twice as much. So I'm up twice as much for the first output, and I'm up twice as much for the second output, and the same thing on the left side. So it looks like we have stretched twice as tall as normal. I'll just say stretched twice as tall. That must mean that the value of A is not 1, but 2. We know that the value of H, because we shifted to the left 1, is -1. And we know that the value of K, because we shifted down 6, is -6. But finding the value of A is important by finding all the other outputs, and they were all twice as tall as normal. So let's write the equation. Let's use once we find A, H, and K, we just plug them right into our general form, and we'll have our equation. So we've got Y, since K is -6, this would turn into +6, because we'd be subtracting a -6, Y +6, equals the value of A, which is 2, and then my set of parentheses, which would be X minus the value of H. X minus -1, of course, is X plus 1, and then the quantity squared. So that's acceptable, of course. Some people don't want to write it as Y plus 6. They'd rather write it as Y equals, and then the 2 and the X plus 1 quantity squared, and then K is just -6. And that's absolutely fine as well. So we've looked at 2 examples. Feel free to go back and look at these again, and we will practice this along with graphing from the equation to the graph next class. Thanks for watching this tutorial. I appreciate the applause.